Welcome to the C programming course series. Even today, C remains one of the most widely used programming languages. C is often taught as an introductory programming language because of its scalar structure and a close relationship with hardware. Based on the TOBE 2024 list, a computing language popularity index, the number 1 is Python, number 2 is C, number 3 is C++, and number 4 is Java. This is very surprising that a language which was actually created in 1972 is still going very popular. In this series, first I am going to dive into the C programming, starting with its history and importance, then the actual C programmers starting from the hello world to the practical applications in the real world. I have summarized the history of C as shown in the following chart. C was developed in 1972 by Dennis Ritchie at Bell Labs. It's a powerful, efficient, and widely used language, especially in systems programming. Namely, C was initially developed for the Unix operating system, which was also being developed at Bell Labs at that time. As Unix spread to various institutions, so did C, establishing its reputation as a powerful programming language. In 1978, Brian Kniga and Dennis Ritchie published a book, namely the C programming language, often referred to as K and RC. This book became the definitive guide to the C and greatly contributed to its widespread adaptation. In 1983, the American National Standard Institute, the ANSI, formed a committee to create a standard specification for C. This effort culminated in the release of ANSI C, namely also known as C89 or C90 in 1989. The standardization helped ensure that C programmers could be more easily ported between different computer systems. After the ANSI C, the C language has continued to evolve with updates like C99, released in 1999, C11, released in 2011, adding new features while maintaining the language's simplicity and efficiency. Finally, C17, the latest stable release, has been released in 2018. However, there is a preview release in 2024, namely C23. During this 52 years history, C has been developed continuously, has been added many new features, specification has been updated. Most importantly, in 1989, C became ANSI C. Namely, there is a standardization in 1989. Since then, C has become a standard computing language. In addition, C's success led to the development of several other languages, most notably C++ in 1982, which added object-oriented features to C. Other languages like Objective-C in 1984 and C# and Java also draw heavily from C. C's development has played a crucial role in shaping the world of programming, providing the foundation for many languages and technologies used today. C is a powerful and widely used programming language that has influenced many other languages. Here are some important properties of C. First, simplicity. C is a relatively simple language with a small number of keywords and a straightforward syntax, making it easier to learn and use. Portability. C programs are highly portable, meaning that code written in C can be run on different types of machines with minimal modifications, as long as a C compiler is available. Efficiency. C is known for its performance and efficiency. It provides low-level access to the memory and the system resources, allowing developers to write programs that are highly optimized for speed and resource usage. Structured language. C supports structured programming, which allows the use of functions, loops, and conditional statements to create clear and maintainable code. Rich library support. C comes with the rich standard library that provides a wide range of built-in functions for performing common tasks like input or output, string manipulation, memory management, and more. Memory management. C provides manual control over memory allocation and deallocation. This control allows for fine-tuning of resource management, but also requires careful handling to avoid memory leaks and other issues. Pointers. C has powerful support for pointers, which are variables that store memory addresses. Pointers allow for efficient array handling, dynamic memory allocation, and the creation of complex data structures like linked lists, etc. Modularity. C supports modular programming by allowing code to be divided into functions and files. This modularity makes it easier to develop, test, and maintain large programs. Extensibility. While C is a simple language, it is also highly extensible. You can use libraries and extensions to add new functionality to the language as needed. Finally, low-level programming. C is often described as a low-level language because it combines the features of high-level languages with the ability to perform low-level programming, such as direct hardware manipulation and bitwise operations. These properties have made C a foundational language in computer science and a popular choice for system programming, embedded systems, and applications where performance and control are critical. In addition, in C, types are static and manifest, meaning that you must declare the type of every variable before using it. The static keyword here meaning that the types of variable indeterminate at the compile time. You must declare the type of every variable before using it. This allows the compiler to check that variables are used correctly according to their type and to optimize the program. Once a variable's type is set, it can change it throughout the program. Therefore, in C, types are static. Then, manifest typing means that the type of each variable is explicitly stated in the code when declared. Unlike dynamically typed language like Python or JavaScript, where the types is inferred or can change at runtime. In C, the type is written out and must be provided by the programmer. C programmers or C applications is cross-platform, meaning if we have a C code or if we have a C application, we can run it in different OS. Finally, in C, we have two types of file name extensions. The first one is .c. .c is used for codes. The second one is .h. .h mainly used for preprocessor directives. In the coming lectures, we will explain all of these important properties of C in details. In this course, I am going to use Visual Studio Code. Therefore, we need to set C environment in Visual Studio. By using Visual Studio Code's extensions functionality, install following extensions from the marketplace. First, we need to install C, C++ extension pack, then install C and C++ for Visual Studio Code, and then finally we need to install Code Runner. Now let's do that. This is the Visual Studio Code. If you don't have Visual Studio Code, please install first the Visual Studio Code. Then, if you have Visual Studio Code already installed, please go to Extensions. Just click this icon. Okay, now this is the extensions marketplace. Therefore, from here, we are looking for the packages we are going to install. First, we are going to install C and C++ extension package, namely this one. Okay, popular extensions for C++ development in Visual Studio. This package was developed by Microsoft, and this is very popular. Please see here, it's already installed 32 million times. Then just install here, click the install. Now it's being installed. It takes some time. Okay, now it has been installed. The second one is we are going to install C and C++ for Visual Studio Code. Namely, we are going to install C and C++ for Visual Studio Code. Therefore, just look for it. And okay, we have it actually. This is the one. C and C++ for Visual Studio Code. Actually, this is very popular as well. Already installed 69 million times. This package is created by Microsoft. Okay, now let's install it. Click install. Okay, it's installed very quickly. Okay, so now finally we are going to install Code Runner. Code Runner, this one. This is also very popular. Already installed 28.6 million times. It looks like this is very popular as well. Actually, after we install this, in the Visual Studio Code, on the top right side, a play button will be installed. When we play that button, actually C, C++, Java, and many other codes will be compiled and run. That's very convenient and very useful. Therefore, we are installing this Code Runner. Okay, now let's install it. Just click this. It has been installed. In summary, we have installed 3 packages. The first one is C and C++ extensions pack, and the second one is C and C++ for Visual Studio Code, and the third one is this Code Runner. Okay, now we have prepared our environment for C development. From now on, we can create C code and we can compile it and we can run it. Before that, one thing we need to check it, namely, is the installation is correct or not. Therefore, we are going to check the compiler's version. Namely, we have installed C and C++ packages. Actually, that packages already installed GCC compiler. Before starting code, we need to check the compiler. Namely, just enter GCC space, then dash, then enter version. Then click enter. Okay, it displays the version number. It looks like we have installed GCC's version 13.2.0. It looks our installation is correct. Therefore, we can use this compiler in the Visual Studio Code. From now on, we can create some C codes and then we can compile it and we can run it the machine. Congratulations! Until now, we have introduced C language, explained its history and some important properties, then prepared the C development environment in the Visual Studio Code. Now it's time to start coding. I just launched the Visual Studio Code. Now let's start coding. First of all, I need to create a folder and save the created C file there. I create the Hello World folder. Now open this folder in the Visual Studio. Okay, now let's start coding. First, I will create the code, then explain it line by line. Okay, I just created the code. Namely, I have created hello.c file. Now we have only one file here. It's the source file. Let me explain this code line by line. First, we have a line hash include then stdio.h. This is a preprocessor directive that tells the compiler to include the standard input-output library before compiling the program. Namely, the standard stdio.h is a preprocessor directive. Then we have the main function, namely the entry point of this code. In C, each executable code should have main function. After that, we have a curly brackets, namely we have a braces open and close. Just this part inside this braces, we call it code block. Inside the code block, we should have some executable codes or functions. We may define a function outside this main block, but when we execute it, we must call that function inside this main code block. This is so important. For example, here we are calling this function, then we are returning this 0. Actually, the main function in C always return integer values. Therefore, here we are returning 0. Therefore, we have here return type in front of the main function. Then, the printf function accepting hello world, namely a string, but I am saying it here an array of characters because this is the first code and we didn't explain the string data type yet. Therefore, I just wrote it an array of characters. Actually, this printf function accepts this array of characters and print this content to the standard output. Namely, inside this double quotation, we can write a string or an array of characters. Then this printf function will print this content to the standard output. In summary, this is a very simple C code, but we can say this. this is a perfect C code. Or I can say that this is a perfect application created by using C language. First, we have a line, namely include stdio.h. We are including the standard input-output library here. Then we have a main function. Inside the main function, we are calling a function. Then we are executing this function. After that, we are returning a value, namely integer value. This is the return type. Therefore, I can say this is an application created by using C. Now, let's execute this code and see the result. Okay, in the previous section, we just installed some packages. Namely, we have installed a package. Its name is CodeRun. Because of that package, we have this play button here, or display icon here. Inside the display icon, we have three menus. First one is debug C and C++ file. The second one is run code, and the third one is run C and C++ file. Now we are going to use the second one, namely run code. We are going to run this code. Now let's do that. Okay, we just run the code, and this is the result. Here we go. It's working great. Namely, this code has been displayed this hello world, this message on the standard output. Then here is the return code. Actually, this 0 is equal to this 0. If I put it here, 1, for example, and execute again, this should be 1. Let's see that. Okay, here, code equal to 1. Namely, this value is the return value, because we just said that in C, the main function always return integer values. Therefore, this is the integer value. When we execute this code, this value has been returned. I just restore it to 0 and execute again. Okay, so then let's see here. Here we have first we have GCC, then space hello.c, then we have O. Actually, this is object. When we compile this, first we create object. After object, and it will convert it to executable file. Actually, when we run the code, first GCC compiled the code and created one executed file. For example, executed file hello.exe. Actually, previously we have only one file here. Now we should have two files. One is hello.c and the second one is hello.exe. Let's see that just here. Here we go. hello.exe. This is an executable file. This file has been generated after we compile it. For example, if I delete this, and then if I run again, that executed file will be generated. Let's see it. Here we go. And the code has been executed here. So, in summary, this is the very simple C code. And I can say that this is a simple C application. In this code, first we are including the standard input-output preprocessor directive. Inside this directive, many functions, macros, data types, and other objects are being defined. Namely, inside this standard input-output header, 4 types of objects are being defined. The first one is file handling functions. Second one is input-output functions. The third one is macros. The fourth one is data types. Now, for example, in the first one, namely file handling functions, we have fopen. Open is a file. We have fclose function, closes and opens file. Then we have fread function, reads data from a file. Then we have fwrite function, writes data to a file. We have fseek function, sets the file position indicator. Then we also have ftell, gets the current file position indicator. We will learn all of these functions in the common courses. Then, as input-output functions, there are a lot of functions as well. For example, the first one is printf. The printf function prints formatted output to the screen. Then we have scanf function, reads formatted input from the keyboard. We have putjar function, writes a character to the screen. We have getjar function, reads a character from the keyboard. We have puts function, writes a string to the screen. However, in the common courses, we are going to explain or we are going to learn all of these functions. Then, as a macro, inside this standard input-output header, we have null, a macro representing a null pointer. Then we have EOF, a macro representing the end of file indicator. Then we have file underscore max, a macro defining the maximum length of a file name. Finally, inside this standard input-output header, we have data types. The most notable data type is inside this standard input-output header is file, a data type used to represent a file stream. Therefore, inside this standard input-output library, there are many functions, macros, and data types. Therefore, this is the library most used inside the C program. However, today I just mentioned that name of the functions or name of the macros. But in the common courses, we are going to learn all of these functions, macros, or data types. Today, just mention that, why we include this standard input-output header in the first line of this simple code. Therefore, I just explained it. In summary, in this first course, first we have explained the C, then we have explained the history of the C, then we have explained some important properties of C, then we have installed some packages in order to prepare the C environment in the Visual Studio Code. Then we have created our first Hello World code. Finally, we have executed it. Then we have explained some data handling functions, some input-output functions, and macros, and then some data types inside this standard input-output header. Thank you for your watching. Please subscribe.